Wildfires are among the most common forms of natural disaster and are responsible for more than 33,000 deaths globally each year. They commonly occur in California, Siberia, and Australia, and areas with Mediterranean climates, or in the taiga biome as well, are particularly susceptible. In middle latitudes, the most common human causes of wildfires are equipment generating sparks, power lines, and arson. In the tropics, farmers often practice the slash-and-burn method of clearing fields during the dry season. They are distinct from beneficial uses of fire, called controlled burns. Wildfires arise when all the necessary elements of a fire triforce come together, such as an ignition source brought into contact with a combustible material, like vegetation, which is subjected to enough heat, and has an adequate supply of oxygen from ambient air. Most occurrences are unplanned, uncontrolled, and unpredictable. Less dense materials such as grasses and leaves are easier to ignite, because they contain less water than denser material, such as branches and trunks. When this balance is not maintained, plants dry out, and are therefore more flammable, often as a consequence of droughts. Risk is exacerbated by variable factors such as human activities, weather patterns, availability of wildfire fuels, and the availability or lack of resources to suppress a fire. Intensity also increases during daytime hours. Fires in Europe occur frequently during the hours of 12 p.m. and 2 p.m. Burn rates of smoldering logs are up to 5 times greater during the day due to lower humidity, increased temperatures, and increased wind speeds. Human-induced geographical and climatic changes are exposing populations more frequently to wildfires and increasing wildfire risk. It is speculated that the increase arises from a century of overcautious suppression, coupled with the rapid expansion of human developments into fire-prone wildlands, since early societies were unaware that wildfires are naturally occurring events that aid in promoting forest health. But at a global level, human practices have made wildfires worse than naturally would happen, with a doubling in land area burned by wildfires when compared to natural levels. People have contributed to major factors to increased wildfires, increased heat, and dry periods due to climate change and other direct human activities, such as land use change. This increase in fires creates a negative feedback loop, releasing naturally sequestered carbon back into the atmosphere, facilitating further global warming. Heat waves, droughts, climate variability such as El Niño, and regional weather patterns such as high-pressure ridges can increase the risk and alter the already erratic behavior of wildfires dramatically. Heat waves are the most lethal type of weather phenomenon in the world. Temperature affects wildfires in the same way. They dry out the vegetation and make them more flammable. Since the mid-1980s, earlier snowmelt and associated warming has also been correlated with an increase in length and severity of the wildfire season, or the most fire-prone time of the year in the western United States. The average U.S. acreage burned annually by wildfires has almost tripled in 3 decades. In California alone, more than 350,000 people live in towns and cities in very high fire hazard severity zones. While the most noticeable adverse effect of wildfires is the destruction of property, the release of hazardous chemicals also significantly impacts health at a less obvious pace. The pollution from wildfire smoke can spread as far as 1,000 kilometers, or 621 miles away. Several epidemiological studies have demonstrated a close association between air pollution and respiratory allergic diseases, such as bronchial asthma. Wildfire smoke is composed primarily of carbon dioxide and water vapor, but may contain lower concentrations of carbon monoxide, formaldehyde, acrolein, polyaromatic hydrocarbons, and benzene. These other chemicals are considered to be significant hazards, but are found in concentrations that are too low to cause detectable health effects. However, the more frequent occurrence and exposure to wildfires will exacerbate their effects cumulatively. Additionally, an often overlooked consequence is the exposure to wildfire debris that contaminates soil and water supplies. After 2 major wildfires in California, researchers found an increase in physician prescriptions for quick-relief medications in the years following the wildfires than compared to the year before each occurrence. Particulate matter triggers a series of biological processes, including inflammatory immune response, oxidative stress, which are associated with harmful changes in allergic respiratory diseases. Wildfire particulate is more toxic than urban fires because of its chemical makeup, smaller particle size, and associated high temperatures. In investigating the association of medication use for wildfire exposure, researchers found increases both in the usage of inhalers and oral steroids. More specifically, some people with asthma reported higher use of quick-relief medications. In the summer of 1974 and 1975, Australia suffered its worst recorded wildfire, when 15% of the country's landmass suffered extensive fire damage. Fires that summer burned up an estimated 290 million acres, or 450,000 square miles. The annual number of hot days, above 35 degrees Celsius, or 95 degrees Fahrenheit, and very hot days, above 40 degrees Celsius, or 105 degrees Fahrenheit, has increased significantly in many areas of the country since 1950. Bushfires had always been common and anticipated, but in 2019, the extent and ferocity of these fires increased dramatically. For the first time, catastrophic bushfire conditions were declared in Sydney, the most populous city of Australia. New South Wales and Queensland declared a state of emergency, while fires were also burning in the south and western parts of the country. Smog, or haze, is another side effect of wildfires, and a regular problem in Southeast Asia, caused by land and forest fires in Indonesia, especially Sumatra and Kalimantan. Farmers and plantation owners are usually responsible, which they use to clear tracts of land for further plantings. Those fires mainly affect Brunei, Indonesia, the Philippines, Malaysia, Singapore and Thailand, and occasionally Guam and Saipan. The worst economic losses occurred in 1997, and was estimated at more than $9 billion. This includes damages in agriculture production, destruction of forest lands, health, transportation, tourism, and other economic endeavors. Not included are social, environmental, and psychological problems and long-term health effects. The second latest bout of haze to occur in Malaysia and Singapore is in October 2006, and was caused by smoke from fires in, again, Indonesia, being blown across by southwesterly winds. A similar haze occurred in June 2013, with the Pollutant Standards Index setting a new record in Singapore on June 21 with a reading of 401, which is in the hazardous range, which is the highest level. In 2005, Malaysia experienced an air pollution crisis caused primarily due to fires. The haze spread across Malaysia from the Indonesian island of Sumatra, leading to air quality reaching hazardous levels in certain states, and the capital city, Kuala Lumpur. The Malaysian government declared a state of emergency in affected regions, closed schools, and held crisis talks with Indonesian officials. The 2005 haze was at the time the worst to hit Malaysia since 1997. In 2019, extreme heat and dryness caused massive wildfires in Siberia, Alaska, Canary Islands, Australia, and in the Amazon rainforest. The fires in the latter were caused mainly by illegal logging. The smoke from the fires expanded on huge territory, including major cities, dramatically reducing air quality. As of August 2020, the wildfires in that year were 13% worse than in 2019. The Amazon rainforest's existence is already sensitive to fires, and can bring upon a catastrophic negative feedback loop, if it gets devastated even further, which it currently is on track to be. According to the World Wildlife Fund, if this rainforest is destroyed, we will lose the fight against climate change, as there will be no going back. In 2021, Western North America experienced an extreme heat wave from late June through mid-July. Rapid attribution analysis found that this was a 1,000-year weather event, made 150 times more likely by climate change. It appeared due to an exceptionally strong ridge centered over the area, creating a dome that trapped heat. It resulted in some of the highest temperatures ever recorded in the region, including the highest temperature ever measured in Canada at 49.6 degrees Celsius, or 121.3 degrees Fahrenheit, as well as the highest temperatures in British Columbia, the Northwest Territories, the state of Washington, as well as a tied record in Oregon. However, the Pacific Northwest suffered the vast majority of the disruption and damage connected with the extreme weather event. The heat wave sparked numerous extensive wildfires, some reaching hundreds of square kilometers in area, which led to widespread disruption on the roads. One of them destroyed the village of Lytton in British Columbia, the day after it had already set a record high temperature for Canada. And in 2022, for the second time in as many years, Lytton was again evacuated as a wildfire threatened homes, businesses, and residents. 2021's wildfire already destroyed 90% of the town of 250 residents in the same week, when the town shattered heat records. Record-breaking wildfires in 2021 also occurred in Turkey, Greece, California, and Russia. The 2022 European heat waves, especially the one that hit Britain, caused extreme temperatures creating wildfires in June and July. Other heat waves have been felt throughout the year, including in the Americas, China, Australia, and the Indian subcontinent, despite being only halfway through 2022 when this video was uploaded. While most scientists attempt to remain optimistic regardless of the data, 2022 broke several records set in 2021, which will likely happen again in 2023. This only makes the chances for reversing human-induced climate change even more bleak.